Okay, so let me just log in. So go to service, so click on submit. Okay, so just click on choose file. So the procedure is actually the same way. Downloads, not download. Instead of searching these files, creating these files is very easy. Okay, so let's create a separate file of protein and this RNA molecule using the PyMol, and then let's submit it here. Okay, or else if you want to take it from PDB, you can type here PDB plus zinc finger motif. Okay, you can see here, so this is the one we have, so we can take it from here also. Okay, what is the PDB ID? 1AAY. Okay, file, open URL, 1AAY, just open. So delete all the water, hetero atom. So there are some hetero atoms actually, you can delete them. So we have A is the protein, and we have C. You can see C is one strand of the DNA and B is another strand of the DNA. Okay, or what is the complex? It is DNA or RNA. It is a DNA. Okay, so first what we'll do, we'll remove B and C here, and let's save the protein file, save as. Okay, let's create a folder for today. Head doc, protein, P stands for protein and D stands for DNA. Okay, protein and DNA. So we have the protein, save as, type PDB, then click on save. So now open the same thing again and now save the DNA molecule. Sorry. So file. I hope everyone is following. AAY. Okay, just delete the hetero atoms, then delete the protein. Now we have only the DNA. Just save this one. File, save as. So go to the folder that we have created now. Okay, DNA. save as type pdb, then click on save. Okay, now both the files have been saved. Now let's submit here in the Haddock server. So what we are doing, protein DNA, let's name it as protein DNA, and click on choose file. So here the molecule 1, let's give the input of the protein. Okay, we have uploaded the protein. Now let's upload the DNA molecule. Choose file and DNA. Okay, then here we have to, what kind of molecule are you docking? So this we have to change. So it is nucleic acid. Then click on, so this is the only thing we are changing here. Okay, so then click on next. Okay, I think there is some issue. Okay, your PDB contains multiple forms. You can see there is no issue with the DNA. There is only issue with the protein at position proline 104. Okay, so this is not, your PDB contains multiple forms of the same residue. Like you guys know how to fix this issue. So let's do it again. If you any one of you have forgot or not able to recollect, watch carefully. So we are taking the protein molecule and we have to open it in the notepad. So one of you, those who are good at programming, you guys can write a program. So as such, once you upload the PDB, and that will automatically remove the B files. Okay, like the B confirmation data, like whatever I am deleting manually, so that has to be automated. Okay, so you can write some program that could be also one decent project. Okay, ma. So is anyone here good at programming?
I'm okay with Python.
Okay, can you think of writing a program for this, ma? Like instead of doing manually, like it should go and edit automatically. So let's check.
Yeah, yes, I can think of a code for that. I'll come back
Yeah,
with the code of that if
okay,
I
you
could
can, yeah,
design.
okay. So we can see for 115 also we have this thing. So we have to delete the B1. So I'm deleting the B1. It's arginine. Even it's like I want to associate with Haddock actually, and like when I discussed with my ideas with one of my friend in CDAC Pune, so I think they might have approached or they approached, I don't know. Like finally the CDAC Pune, my friend's team only is working in close association with this Haddock. Okay, we have another residue also 309 at position 123. Okay, we have glutamine. Okay, we have leucine at position 150. So instead of uploading multiple times and wasting our time, I'm just cross checking every amino acid here, and we are trying to save the time actually. Okay, but now we have cleaned the entire protein for the B conformations. Now let's upload again. We have the protein and the DNA. Okay, so then click on next. Okay, you can see now the molecule has moved to the next step. So you can select, actually you have to, as you guys already know, you have to do the analysis and identify the active site residues, but here I am going to give some residues randomly, like 143 to 180. You can give all the numbers 1 to 41. Okay, then click on next. So don't worry about this thing. Easy access level allows you to check default, expert. So these all things are nothing for us. We are doing only the docking. We are not running any simulations here. Okay, so you can come down, then click on submit, then click on no. Okay, you can see now the file has been submitted. Okay, so this is with the protein DNA part. Now let's look at protein RNA also. The same way you are going to do the protein RNA also, but from my end, let me give a demo part. I think I opened it in time, alright. So now you can see this is the RNA one. So can you check and confirm me whether it is DNA or RNA? Can you check the sequence? Yes, ma. Is it DNA or RNA? Can you all see the sequence here? Yes. How many of you are active? Now tell me, ma, either it is DNA or RNA. Can you see the nucleotide in this? Is my screen visible? Okay. So now, yes, ma, it is DNA or RNA. What is the difference
RNA?
between DNA and RNA?
Is it RNA, sir?
Yeah, on what basis you are saying it is RNA?
Single strand. I mean, I might be wrong, but it's looking single strand to me.
What is the difference between DNA and RNA, ma?
Single stranded, double stranded, and uracil and thymine difference. OH group
I am,
difference.
yes, ma, I am displaying the sequence on the top. Can you see the uracil there?
Oh yeah, I can see that.
Yes. So
RNA.
we have uracil here. So it confirms that this is an RNA molecule. Okay, ma. So now we have to save this both the DNA and RNA separately. So I am selecting entire RNA molecule now. I'm just renaming it as rename selection RNA. And now in this next case, I am going to select all the residues till this 266. Okay, what is the residue number? Okay, yes, to select all the residues, I am not going to drag. So I'm planning to use a command. What is the command? I want to select the residues from 1 to 266. What is the command we have to use? Yes, any one of you remember the command? Have you written in your notes? Just you can turn the pages and
Yeah. So is it SELE?
yeah, SELE space RESI, okay, 1 to 266. Okay, now you can see all the residues has been selected. So it is total we have 267. So let's make it 267, and you can see all the amino acids of this particular protein has been selected. Okay, so now actions, rename selection. So I'm naming it as protein. So now go to file. Let's save this both of them separately. File, export structure, export molecule. So here in the selection we have to select only RNA. It means only the RNA molecule will be saved. Okay, then you can leave this last option, save. So I will save into the same folder that we have created today, or else we can create another folder also. Let's create another folder, doc protein RNA. Okay, so I'm saving this as RNA, save as type PDB. Just click on save. So now the protein has been saved. Now let's save the protein. Sorry, RNA has been saved. Let's save the protein. So go to export structure, export molecule, and the protein PDB options. Then click on save. Protein. So save as type PDB. Then click on save. Okay, if you want to do a cross check, we can do a cross check also by opening. So when I click reinitialize everything, everything will be deleted. So I'll just open the molecule that we have saved now one by one. So first let me open the protein, and you can see only the protein is present. Okay, this is done. So let me reinitialize. Now I just want to check the RNA molecule also whether it is saved correctly or not. So open RNA molecule. So you can see the only RNA. Okay, so we are done with this process. Now let's go to haddock and submit the protein DNA docking. Okay, sorry, I have to click on submit. So there, protein RNA. Okay, choose file. See, most of the things the steps are repetitive, but my intention is that uh, you at least if you listen more times you'll able to remember, because most of you are not writing notes and most of you are not practicing also. So then click on choose file, then RNA, then click on open. So now here we have to what kind of molecule here? Nucleotide. So if I am sure 5 out of 10 people won't select nucleic acid here, and they'll tell the haddock is not working. Then click on next. Okay, there is some issue with the file histidine. Okay, so this histidine residue is actually modified. Okay, we have to rename either it as het atom, or we have to modify the residue name as HIS. Okay, so now let's open. So this is also one of the error. Suppose sir you are expert, so you are telling us directly what to do. So you suppose you are a beginner, now you don't know what to do, just click on this headout library. Okay, ma'am. So today I am teaching this tool and you are free to ask me about this tool. But tomorrow, if you are reading your own tools, like if you are working on your own set of tools, some new tool, now you don't have anyone to teach, then what you have to do, you have to refer the support pages. Okay, ma'am. So just click here HIE, control F and HIE. Let's see whether we can find anything. So we can't find anything. You can see this one, NEP, any postulated histidine. So you can see the list of modified amino acids. We can have ACE, so N-terminal acetyl group, ALY for acetylated lysine, ASH for protonated ASP, and CFE for cysteine with iron sulfur cluster. And you can see phosphorylated cysteine is written as CYP. And I think in this we don't have that histidine thing. Okay, so NEP for phosphorylated histidine. So what we have to do, let's go to the our page once. What's HIE? So you don't know what is HIE. So HIE plus modified amino acid. So okay, ma, you can see here what it is saying. In the N1H tautomer, NH group is nearer the backbone. These neutral tautomers are referred as N epsilon or N gamma, N delta, or sometimes referred with the symbols HIE and HID. Okay, so there is only, it is a tautomer, it is representing a tautomer, or it is not a phosphorylated histidine. Okay, so in that case what we are going to do, you can see if it is a phosphorylated histidine we have to type NEP. So this is not a phosphorylated histidine, so it is just it is a tautomer of the histidine. So we have to go to this protein, okay, sorry, protein DNA folder, right? Protein RNA folder. So open the protein, open with notepad. So what is the number exactly? It is at histidine 40. Okay, so go to the 40. Okay, here we have 40. So we have to replace this HIE with HIS. Okay, so we can have the edit, find and replace HIE with HIS. Okay, we can just click on replace all, and now just go and cross check position 40. Okay, everything has got replaced. Okay, just save this one. Now come back and upload it. So even when I was doing any molecular dynamic simulations, I used to read a long 1,000 page uh, what I can say manual to fix the errors, or I used to put the same error code in the Google and I used to check is there any answer. Okay, let's check the haddock library. So as we are using this RNA molecule, so it should be heteroatom. Okay, okay, these are the supported residues. If it is adenine DNA, it should be DA, DC, DG, DT. If it is RNA, we should have A, C, G, E. So now this file RNA, open it with notepad, and you can see it is written as atom here, and actually it should be here. They are already telling us that should be using at atom record. Okay, we have to replace this atom with h at atom. Okay, so let's select this one till this space, because the spacing is very important. Okay, so replace this thing with no, just 1 second. I will replace first this one with H E T A T M. Okay, so okay, now we are done. Copy, replace. Okay, this one also I will copy and paste because I don't want any mistake with the space. Okay, replace all. So now we are done. Just save this one. So let's upload this file also. Okay, then click on next. Okay, again there is some error. Let's see what is the error. So protein is fine. Okay, we have not selected as a nucleic. So that is the one. As I told you, 5 out of 10 will forget. And now in process of focusing on these errors, even I also forgot to select as the nucleic acid. Okay, they are asking us to select this as the nucleic ligand, not as a nucleic acid. Just let me open this one once. Okay, here we have given it as U5. Okay, so let me open this DNA molecule and see what it is there. Okay, here it is given as DA. What is the difference? So as there is a word 5 here, it is not accepting this as the DNA molecule, that is RNA molecule. Okay, so simply what we have to do here, select this thing, or else simply you can select it as ligand and you can do that process also, but I don't want to do that. So I'm just replacing this U5 with space U. Okay, so that everything will be in the same line. You can see here this guanine and this thing are in the same line, and there is some issue with this one should come this side. Just let's cross check. Okay, replace all. Okay, it's fine. Then click on save. So now let's give a try. So select the protein has been selected. Now we have to select only this molecule, RNA molecule. Okay, just scroll down, then click on next. I hope all the errors are fixed now. Oh my god. Okay, so there is one line here. It is saying atom. Actually we have replaced, right? Let's go to the notepad. You can see. Okay, one line has got replaced. Okay, I think we didn't save this one. So this atom. Okay, actually I have clicked undo before, so that's the reason this got changed. So this atom, edit, replace. So this we are going to replace with 8 atom. Okay, previously I was clicking undo multiple times, because of that it got changed. So just choose file, RNA, open, choose file. See, I am trying to fix error over live because it's not. I just want you to know how many errors would going to you guys going to come across in future, and you will know like how to fix them. Okay, as I always say, if there are no errors in the process of doing your work, it means you have learned nothing. Because even your the sibling who is going to school, he can also do this submission process. Okay, ma, it's just asking us to select this one as ligand. Okay, because as we are not able to fix this error, so let's select that as ligand and we'll see whether it will go ahead. Okay, actually. And sometimes we need to compromise because it's asking us to select as ligand. Let's see whether it works or it will throw some other error. Okay, it has thrown another error. So now let's see what it is saying. 4227, that should be using atom record. For some molecules it is same atom. Okay, let's try to replace this thing with atom and see. Yes, ma. How many of you are still active, or you are bored of this submission process and doing your set of works? So actually, what happens whenever you are doing work on any particular protein or file, you have to take either of them from the protein data bank. Okay, so like if you take from other source of files, then usually we'll face this kind of issues. And at line 19 there is some unexpected issue. It does not meet any criteria. So where is the line 19? We have to count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19. Okay, this problem would be continuous because we have too many atoms with this set of configuration. So just a second, let me take some other molecule. Or else the thing is that we have to take this set of protein from the PDB files, and then we have to go for the docking. Okay, we'll do one thing then. So this issue is because I'm taking a files from a different source, okay, which is not in readable format for the ad hoc. So that is the reason we are coming across the many issues. If you look at the protein DNA docking, what we have taken, I have taken the PDB from the protein data bank, and there was no issue at all, right? So I'll do one thing, PDB plus RNA plus protein. Okay, we can, let's take this structure 3WBM. So you can see here, let's take it in PyMol, because I know you guys are well like better in a way of dealing with Discovery Studio, so that I just want to give you a demo in the PyMol, like how to save the structures. And the analysis part for this protein nucleotide will be a bit tricky actually. So it's like it will be like more like Greek and Latin for you guys, because the words you have never heard you will be talking about. 3WBM, and it will be of this thing itself is of high standard for you guys, this course itself. And when we talk about this analysis of protein DNA docking, it will be of much higher standard actually. Okay, and usually you might have never heard such terms, and we can do it in a simple way also, like in terms of bonding, number of bonds between the DNA molecule and the protein. That is a simplest way, but uh, like we'll do some comparative analysis also. What happened? Okay, so you can see here now the protein and the RNA molecule are visible. So let's confirm that it is an RNA. Okay, you can see there are some uracil residues here, confirming that it is an RNA. So now first let's delete the water molecules. Okay, and you can see here we have two strands, okay, of the RNA. It means it is a double stranded RNA molecule. And in my case what I have taken, that was a single stranded RNA, but it is forming a loop like structure. Okay, so here we are going to select this RNA molecules completely and save it as RNA. Now we select the entire protein, all the protein chains. Okay, we have A chain, B chain, C chain, and the D chain. So I'm typing SALE chain A plus B plus C plus D. Okay, all the chains has been selected. Then rename this thing, rename selection to protein. Okay, so now go to file, export structure, export molecule, PDB options, then save. Okay, go to the folder. So now I will save this one as 3WBM underscore P and save as type PDB. And I think I have done something wrong here. No? Export molecule. Here in the selection we have to select only protein, then click on save, and we have to save only the protein. Okay, just click on PDB. So this one I am replacing the file. Okay, now only the protein has been saved. Now save the RNA molecule, export structure, export molecule. Then in the selection, select RNA, then PDB option, save. 3WBM underscore RNA and save as type PDB. Okay. So if you want, you can cross check, or simply we can go back to the DNA molecule, sorry, Haddock server, and save, submit the files. Protein, 3WPM protein, and select the second molecule, choose file, (3WPM RNA). Okay, now here you select this as nucleic acid, then click on next. So one way, other thing we can fix is that we can save the same PDB in open variable and we can fix that errors. So here the problem is that we have different chains. We are trying to select all the chains and there's problem with the numbering. So let's try to understand the error and this notepad file. No? So you can see we have x1 and we have also y is also 1. Okay, so multiple chains with overlapping numbering. The numbering should not overlap. Okay, that is the thing here. So if you see this DNA file, this one, here also we have two different chains. Okay, DNA one strand and the second strand. Let's see here how it is there. So we have B chain and you can see here there will be a C chain started, but you can see the numbering, there is no overlap in the numbering. Okay, so this is the problem with our this thing. So we have 1 here, so 1 2. Are you able to follow, guys?
Yes, sir.
Okay, so we have this x6, it means x is chain name and 6 is the number. Okay, and we have x9, x10, x11, 13, 14, 16. Now we have again 1, that is the problem. Okay, so till now here we have 25. Either we can have 26 here or we can have a different number, not the same numbers. Okay, so we can have 31. Okay, so all ones should be made 31. So we can also make a note. This is also one error we can fix apart from that different confirmation thing, numbering also. Or we can make 25, 26. It should be, it can be continuous also. This is 32. I don't know. Okay, there are a lot of rows to change. So one thing for the time, I hope you understood the error, what has to be done. So for the time being, what I will do, I will delete this Y chain. Okay, ma. One thing is that I can delete in the PD, open in PyMol or Discovery Studio, I can delete. And another way I can delete here also directly in the notepad. just save it, and now let's see how it will works. So there is same problem with the protein file also. We have the same numberings. So this is the protein, right? Okay. And let's cross check. The error is that the numberings are same. So we'll cross check once. So you can see here A chain is starting with the 5 and the B chain is starting with 7. Okay, ma. So it means it is 5 means here 6 7 is there. Again here also we have 7 and other numbers. So there is a overlap of the numbering. And again you can see here again we have 7 5 6 7. So because of this similar numbering, so this is the issue. So now we'll do one thing. Let's delete the additional protein chains and let's do the docking for now. Okay. Or else we'll do here one thing. Select only chain A, then file, actions, rename selection, just name it as A. So file, export structure, export molecule, PDB options, save. And I'm just going to replace the file one. Okay, existing one, this one, save. Yes. Okay. So now let's upload, choose file, and the protein, and here choose file. Yes, ma. Any doubts? I no, today I'm not giving a break. No worries. We'll wind up session in some time. Then click on next. Okay. Okay, but there was some signal issue. I think it got reconnected. Let me share my screen. So hopefully let's try to I think it will work this time, and we'll wind up with this protein DNA RNA docking submission process also. Protein RNA, so here choose file, Okay, one second. I think we have to save this file, right? Export structure, export molecule. So in the selection, let's select this A, then click on save it. Let's see. So let's do a cross check. That is what we have not doing since this time. So let's open the protein and we'll make sure that there is only one protein chain here. Okay, there is only one protein chain. So let's make sure with the RNA also there is only one chain of RNA. Okay, yeah. So now let's submit this thing. So choose file. Okay, ma. You can see now it has passed to the next step. So just select some residues randomly. Then click on next and scroll down and submit. Yes. So this is how we are going to submit the protein and RNA file. So the same things, the only thing, the process of submission is same whether you are doing protein ligand, protein peptide, protein DNA or protein RNA. Only thing is that you have to read the errors with the input file and you have to fix the errors. Okay, ma. So if there is a modified amino acid or modified protein, that should be supported by the head doc, or even if it is not supporting, then we need to read the like their library and we have to modify the files accordingly. Okay, so this is the take home message for today from the errors that we have discussed. Okay, so uh, like if you have any doubts in today's session, you can unmute and ask. So I have asked you guys to decide upon a project. So if you are decided about any project, you can discuss with me today, tomorrow, and tomorrow we'll be having a session on molecular dynamics simulations, like the theoretical aspects and what we are going to do, the practically, and how the things work. Okay, the theory behind it and the practical thing. We are not going to do the practicals for MD simulations, but let's try to understand what is actually done in the MD simulations. What is the difference between the docking and molecular dynamics simulations? So that we are going to focus in tomorrow's session, and we'll try to understand the differences and similarities between the both the tools, and at the end point we'll come to conclusion why molecular dynamics simulations are at an higher end than the docking. Okay. So if you have any doubts, you can unmute and ask, ma. So kindly work on your project part. Okay. And it's like, so if you want me to repeat anything from the starting point, that you can ask me in the tomorrow session. Okay. Yes, Nikhil, would
Could
you
you
like to say
repeat
something?
the mini projects, sir? What should we do
Which one, ma?
about the projects, sir?
Project. So one thing, you just select some topic, ma. So I have given some reference articles, right?
Yes, sir.
So which are based on protein ligand docking. So we can select some project like protein docking based also, or protein DNA or protein RNA based docking. So that you can decide based on the your interest actually. Okay. And once I will discuss with your faculty, like whether we can give an individual project or whether if there is any possibility to give a group project. Okay. So based on that, I will give complete information from my end
Yes, sir.
tomorrow. Okay. So meantime, if you wish to work on any specific topic, so that you just read something on that. Okay.
Yes, sir.
Okay. So thank you all. So just I have want you guys to be more active uh, and learn more. Okay. So once so hopefully we will be done by tomorrow's session, or we can have more 1 or 2 sessions based on the requirement. Okay, ma'am. So anyway, like for doing the projects, we'll be keeping in touch uh, throughout the project time. And when you are planning, I think on the 18th you have to give an exam, right? So are you all ready to give an exam on 18th? Yes, ma. So the exam pattern and all other things also, let's discuss tomorrow if the time permits. Like after we are done with that MD simulation session. If not, we'll discuss day after tomorrow. Okay. Okay, ma. Thank you all. I'm signing off for today. So I will share all the